Hello everyone, in this video I'll be explaining exercise 29 on page 17. This exercise is about the braking distance, which is the distance you travel after you hit the brakes very hard. To calculate this distance we are given the following formula. The distance d in meters equals 0.005 times the velocity squared, with velocity in kilometers per hour. So with question A, they ask to calculate the braking distance for a speed of 60 kilometers per hour and 120 kilometers per hour. So first start with V is 60. We calculate the following. D equals 0.005 times 60 squared. Well, in this case, you first have to calculate the power, which is 0.005 times 3600, and then you multiply these with each other, which gives you 18. All right. The same thing works for 120 kilometers per hour, which will be written like this. So we have 0.005 times 120 squared, and you first calculate the power, which is the following. All right, and these two multiplied with each other equals 72 meters, and this as well. Okay. So this is just a matter of filling in the velocity and calculating the distance. Question B is a bit different because Berend says that if you drive twice as fast, then your braking distance is 2 times longer. Well, let's have a look, because we have already filled in two velocities. And one is twice as fast as the other. So let's look. If we have a velocity of 60 and a velocity of 120 kilometers per hour, then the distance with 60 equals 18, and the distance with 120 equals 72. So if we, from 60 to 120, we multiply by 2. But if we go from distance to the new distance, we don't actually multiply by 2, because 2 times 18 is 36, but we multiply by 4. So what Berend says is incorrect, because when the velocity doubles, the braking distance quadruples, which is 4 times as long. So Berend is incorrect. And then we have question C, and there they ask, there is Jasmila, and she drives into a stopped car, so she crashes. And the braking room was 60.7 meters. Okay, we'll remember this. Jasmila says that she was only driving 55 kilometers per hour. And we have to find out if that's true or not, and why that is. Well, let's say she was traveling 55 kilometers per hour. Then we can calculate the braking distance for that. So let's fill that in. So we have 0.005 times 55 squared. And 55 squared gives us the following, is, let's see, 3025, and these two multiplied give or take, let's see, 15.1 meters. Okay, so now we need to know if she's telling the truth. Well, If she really was traveling 55 kilometers per hour, then she would have enough room to stop before crashing into the car. But she did crash into the car, which means that her braking distance was longer, which also means that she was traveling faster. Because otherwise she would have stopped before crashing into the car. So Jasmila is wrong. All right, I hope you understand everything, and I will see you next time.